In this video, we're gonna learn the basics of the Sentaurus TCAD software and how to get started. So let's begin. After opening your Sentaurus uh, TCAD file in the VMware workstation, you will get a window like this. Okay. Then right click in your mouse and go to the open in terminal. And here you have to give the SWP and press enter, and you will get a workbench window like this. And now we will we're gonna understand what does the workbench means. Here we can see, if we click into this section, uh, here are some module. In this example there are three kind of module. One is S-process, one is S-device, and then S-visual. S-process is help us to design a device from scratch, and S-device is to see the characteristics of that particular device, and S-visual is used to plot that characteristics. Okay, so at first let's see how we can run this workbench. First, go to this section, project home media Sentaurus to 2017, open it, go to any one of the example, then just Ctrl C. You can Ctrl C this thing, and you have to paste it in here. In my case, I already pasted it and give them a run. So to learn this, I'm going to do this once again. Let's see. You need to just right click it and then press copy, then click here, or click, you can make a new folder, you can name it as you wish, and you can paste it down there. Okay, so here I can paste it. Now in this particular folder, under the home Sentaurus HTTP, we can run any kind of workbench. So here we can select the ldemos2d file just like this, and we can click the right section and can run this section. Okay, and then we can run the S-device portion, this S-device portion, and so on and so forth. After running this section, you will get this blue line. Okay, to understand this, I give you an example. Let's just click this portion. Okay, click it and then click run. Oh, sorry, I made a mistake. Okay, the green color is mean queued, and then this color means ready, and then this is called pending, and here we can see the running. So this FP is running and this portion is queued. Okay, so after completion of this running, you can find the example just like this. Here yellow color means the run is completed, and we can observe the characteristics in the S device, and if you run the S visual, the plot will be automatically come in front of you. Okay, and this pink color means your run is aborted. You can easily stop your run by here. Let's see, you can just abort it. Okay, just select all the code and abort it. Okay, also you can do it by clicking the project file and then go to the project and just clean up. Okay, so cleanup will delete all the data in this after the run, which change the workbench. You can just clean it and it will get as new as before. Okay, so let's observe the output. Okay, so in this section you can try visualize thing as a TTR file. TTR file means the device. Okay, let's just observe the TTR file in this section. So here is our 2D mouse device. If we try to get what kind of thing is this, you can zoom in here, okay, and go to the results part to learn about the materials and which portion is built of what materials, and in the line section you can get the idea what is source, drain and gate in here. So if we click this drain portion, you can see that this right portion is gone. That means this right part is the drain contact. Okay, and similarly if you look at this gate, click on this gate, we can understand that this portion is gate contact. Okay, and similarly here this portion will be source, the left one. And if we try to get the substrate, let's zoom the down section. Okay, let's just click on substrate. You can see the substrate is the lower portion. Okay, so this is it. This is the basic of the TTR file. Also, one thing I need to mention, sorry, uh, if we go into the SDFX portion, okay, please, I have to run this once more to see another thing that I have missed. This figure is a token concentration figure. You can change as you like. Okay, so net active. If we unclick the net active portion, you can see the silicon in here. The oxide layer is here, and if we zoom the picture, the middle portion is the polysilicon part. This yellow one is nitride. You can also get this idea from here. Okay, this is nitride 1.1 and the right portion is nitride 1.2. The middle portion is the polysilicon and the lower portion is silicon. Okay, and how do I understand this portion is oxide? You can check it in here. Okay, also you can see the meshing portion. You have to we will understand how we create this meshing portion later on this tutorial. Here one thing we can observe that in the interface region the mesh is very dense compared to the non-interface region. Okay, uh, it will be similar for the silicon region also. Here in the interface the mesh is very dense. Okay, but the farther we go the mesh will be less denser compared to the interface. Okay, so this is it. Let's check out the SDFace portion. Go to the visualize section, Sentaurus visual. So in this SDFace code we plot mainly IDVG. Okay, so let's visualize it. To run IDVG, you have to select the file first, then we select the gate and out of voltage at x-axis, and we can select the drain and total current to left y-axis, and this is the IDVG part. We can export this data by clicking export xy data, export, and then we can name it and export it in this particular file under Sentaurus SADB under PCD field folder. Okay, this is so easy. Let's check the IDVD curve, IDVD family curve. Okay, so similarly in this code I change a few lines to plot the IDVD family curve. Let's just visualize it. Okay, yeah, you can select this part. This is not the right one. Yes, new as visual workbench. So let's first just select all the file and then frame. We are plotting IDVD family curve now for different VG. Okay, so drain outer voltage to x-axis and drain total current to left y-axis. Okay, somehow this uh, file got corrupted, so let's check another one. Let's just check this code. And then new visual. Then just select this portion, click the drain part out of voltage to x-axis and total current to left y-axis, and we got the IDVD family curve from here. Okay, and similarly we can export this code. So this is for this video. We'll see the further on our next video.